So my name is Alec Isaacson. I am a solution architect with New Relic. I'm based in Cleveland, Ohio, which is where you're hearing from me, or you're hearing me from today. Because of the coronavirus, of course, we're all locked down and sheltered in place. So you're going to hear from me remotely. I hope this works out well and everybody hears me, and this is, we get some good feedback going. I'm accompanied here by my own life-size Chewbacca, who's going to help to keep us all company. And we'll talk about how we can measure developer efficiency. So let's get started. Let's get started once my screen decides to play nice. There we go. Okay, so here's what we're going to talk about today. We're going to start with some background. Then we're going to talk about how we can observe the development lifecycle, that is capturing key metrics and annotating performance information. Then what we're going to do is we're going to talk about how we can measure code performance, that being how we can adopt observability, instrument everything, and then begin continuous improvement processes. So let's start with the background. As we all know, you guys are all DevOps practitioners. I spend a lot of time hanging out with DevOps practitioners and work to understand and develop best practices to help you. As we all know, software delivery practices are evolving. We're going, way back in the day, we did waterfall. Then we went to agile, and then all the tooling started to appear. And so we're getting continuous improvement, continuous delivery, and so on. But what this really means is we're going from large teams that had lots of interrelationships and interdependencies to much smaller teams that are autonomous and self-service. Like it says here, modern software is delivered by teams that are leveraging common technology stacks and common tooling, but they're delivering small microservices, which then interact with each other, which are clicked together like Lego building blocks almost, to create the larger services that you're delivering out to your customers and to the world. The other thing that's being added are automation and programmability. Why? Because developers, like everybody else, hate toil. They want something that's quick and easy so they can spend time working on the good stuff, the cool stuff, the interesting stuff. So they want, and they're using ways to automate, building their apps, deploying them, reducing the toil, and improving reliability, because automation and programmability takes the human element out of it. It reduces the chance of user-induced error and inconsistency. And finally, what it means is that now seconds count, not minutes. Because CI/CD is can be deploying many times a day, and the changes are smaller and more frequent, you need to be able to instantly understand the impact of a change, the impact of a new deployment, and detect if it's problematic and roll it back. That's why we get things like canary deploys, that's why we get blue-green deploys, and the rest. So what does that really mean if you're adopting all those practices? It means two things. It means you've got more to track, and you have to go faster. Now, many people see these things as mutually exclusive. Wait. I have to do more, but I have to do it faster, and that becomes a real problem. But as we can see from the state of DevOps, the top DevOps performers are doing this, and they're doing it really well. They're deploying substantially faster. They're deploying more frequently. Their MTTR is much faster. Their time to understand when there is a problem, and their failures because of changes are substantially lower, 7 times lower. So how do you do this? How can you do this? My suggestion and our recommendation is to follow a specific runbook for measurable DevOps success. And it's really got 3 high-level steps. The first one is to prepare. In other words, you need to instrument your applications and you need to establish baselines. That's going to help you to get value very quickly. The second thing you need to do is you need to activate. You need to get fast feedback and understand the impact of every change. That's going to help you to build on your successes. Little successes, a step at a time, get you more successes, get you better. It creates a virtuous cycle. And then finally, what that virtuous cycle plays into is optimization. You can continuously improve what's going on. You can add more automation. You can create more tooling, you can create better processes, more efficient processes to make things better and to keep that virtuous cycle going. That helps you to reap long-term benefits. So let's unpack that a little bit, because there's some really important stuff to understand in here. First, let's talk about preparation. So when you're preparing, you need to be ready for the 3 things you see listed here on the left: app remediation, establishing your objectives and your baselines, and setting up proactive alerting. Why do you need to do this? You need to be able to diagnose and resolve your application problems. You need to set your service level objectives, working in concert with the business, and then the alerting is going to tell you where the problems are. And of course, you need to fine-tune those alerts, as everybody knows, especially those who are familiar with SRE practices. Alerts are things that should be exercised. If an alert is running, if an alert is being tripped too much, you need to adjust it or figure out what's going on. If it's being tripped too little or not at all, it should come out. Then we've got activate. What do we need to do in order to activate our teams to help them understand their place in the world and how they're doing? Well, that's easy. You need to establish team dashboards so that you can share the insights, so you can share the hard numbers across the team, the stakeholders, and the wider development organization. You need to iterate and you need to measure your impact. In other words, as I deploy, as I make changes, what is the impact of those changes? You need to add orchestration tools, because that is going to reduce the risks of human-induced error again. And of course, you need to stop every once in a while, and you need to learn from your incidents. At New Relic, we call things like, New Relic and elsewhere, we call those retrospectives. That's sitting down, looking at your major incidents and understanding what's going on. I've worked with organizations that say, well, we don't really have time to do that. We have to deliver code. And I'll tell you what, it's a big mistake. Unless you can sit down as a team periodically and look at your mistakes and look at your problems and figure out how to fix them, and instead, if you just wallpaper over them, one day something ugly is going to pop out through that wallpaper, and that's really not what you want. And then measuring your code pipeline, understanding how quickly you're delivering code right now, and whether or not that rate is accelerating. And I'll tell you that not only is that going to be important to you as a developer and those who manage developers, but that's going to be important all up and down the chain, because if you can prove the value of yourself and your development teams to IT management and to business management, then they keep you around, they meet your requests for resources, when you need to grow your team, when you need more stuff, when you need to have that offsite, they'll meet those requirements, as opposed to seeing you as a necessary evil, at which point all they want to do is turn the knobs down and reduce the resources and spend the bare minimum on teams like that. And then finally, there's optimization. Understanding your dependency risks, not only dependencies inside of your applications, but dependencies between applications. Where are your key bottlenecks? Understanding your customer experience. And this is really why we're all here, because your customers are the lifeblood of your business. If you're not working with them, if you're not understanding what they want, they're going somewhere else. And they may or may not be telling you that they're going somewhere else. So you need to understand what their experience is, what their understanding is, and what their perception of your brand is. Because if you're not, that's a real problem. You need to make sure that your infrastructure is properly sized. This comes back to user experience and performance. If your infrastructure is too big, if your infrastructure is oversized, you're spending too much money, not good. If your infrastructure is too small, you may be spending too little money, and certainly that's impacting performance and perhaps causing your users to go elsewhere, your customers to go elsewhere. Automating your instrumentation. Let's reduce the toil for the developers. They want to write code, and I've had many developers come to me and say, look, I want to write code, I want to implement new features, I want to do the cool stuff. I don't want to spend time writing back-end code. I don't like that. And I certainly am not a monitoring engineer. I don't want to spend time writing monitoring code, writing instrumentation. So ways to help with that are critical. And then finally, again, an operations review, looking across the entire operation to make sure that you are delivering, you're meeting your service delivery requirements and your targets. All right, so why do you want to do this? You want to do this because it helps you to do the things you see here. It helps you to deliver new code faster. It helps you to improve your user experience. It helps you to increase business value. It helps you to meet your service levels and reduce your errors and have the best response time you possibly can. All right, and the background. So let's talk about observing the development lifecycle. So in this case, by development lifecycle, what I mean is in this case, what I mean by development lifecycle is, what are my developers doing? How long is it taking for me to get from idea to actual implemented code that people are using? And there are some key questions in here. Again, how are my developers spending their time? Which boils down to things like, how long does it take to go from a feature request to working code? Efficiency, how efficient are my developers? Are they spending their time writing new features, or are they spending their time writing fixes? What parts of the code base are they spending their time on? Is our code quality improving? Are we passing our unit tests? How good is our code coverage? How comprehensive are our unit tests? Are we increasing mean time between failures? And the most critical one, can we relate development activities to application performance? If we can do that, if we can relate development to performance, and we can show that to the business in simple, easy ways, sorry, not coronavirus, I promise. If we can relate that, then that's really where you show value and where you can drive continuous improvement and show continuous improvement. And finally, are our processes working? So there are some key metrics that we need to collect in order to be able to answer those questions. At the developer side, commit information. Who's authoring the commits? When are they happening? What is the ID of the change? And I'll show you why change ID in particular is important in a bit. What is our CI/CD pipeline looking like? When do the stages stop and start? How long are they taking? And are they succeeding or failing? What is our unit testing looking like? How often are we running our unit tests? Are they successful or not? What is our duration? In other words, how long does it take for a feature request to be implemented? Now, duration in this case means I'm going perhaps from a new story or a new epic to all the way through to deployment, or it can be a little further down the line. It can be from the first time I create a new branch down to implementation. And again, code coverage. And then how do I relate my development application performance? We do that two ways. One way is with deployment markers, and a deployment marker is simple and easy. All it is a way of saying, at this point in time, I'm telling my observability platform, at this point in time, I deployed new code, and I want you to tell me the difference between the old code and the new. And then the ability to enrich my performance events and metrics with the code version. And I'll show you some examples of that in a couple of minutes. Hopefully everybody's with me on this so far. It's always nice when you're in a room because you can look out at everybody and you can see who's looking on their phone and who isn't. Here, all I'm looking at is a computer monitor, but let's plunge on. So what I'm going to show you here are some sample dashboards that I've created for customers that answer some of these questions. Here we're answering the question, where are my developers spending their time? And so what I've done is I've taken metrics from GitHub, and I've taken metrics from my CI/CD pipeline, in this case Jenkins, and I'm feeding them into my observability platform, and then using that information to generate dashboards that show me these things. So we can see, where are we spending most of our time? In commits per branch. So most of our commits are coming in the development branch of our code. This is good. This means developers are working on new features. They're spending a little bit of time working on the release, and they're spending a tiny amount of time working on the working on hot fixes, meaning working on fixing production problems. This is good, and as you measure this, you always want to see working on the release and working on the hot fix, the percentage of time spent on that going down, because that means that your code is getting better. Then we can look at commits by product, commits by user, and I've covered up some of this just to maintain customer privacy. Modified files, commits by day, and lines of code committed. So I want to break away for just a moment from this, because this is all very important stuff to know, but I want to talk to people who spend their time managing developers right now for a second. Please don't make the mistake of using number of commits by developer as a measure of efficiency or as a measure of productivity. I don't know if Jack Welch, who ran GE, has an old saying, which was, show me a company's comp plan and I'll show you their corporate culture. This is one way. If this is connected in any way to developers comp or developer advancement, the number of commits or the amount of commits they're making, then what you're going to start to find is people are going to start making unnecessary and useless commits. You're going to go from high levels of productive commits to 1 and 2 line commits simply for people to get their numbers up. Don't do that. I've seen customers do it. It's a mistake. Let's look at some other dashboards here. We can look at things in time. Looking at their time is important. How many commits am I getting per application here? And then what days of the week are they happening? And what we can see is, for some of these apps, like OneID, we get commits pretty much all through the week. For others, we only get a few. Now, this may be expected and this may be good, that I want all my developers working on OneID, and if I'm seeing commits in other applications that they're working on, I've got problems. They're getting distracted by other things. In addition, understanding when the commits are coming is important, because if there's a lot of Friday commits or over the weekend commits, then you know that perhaps there are production problems outside of hours. Nobody likes working those, especially the on-call people. And so you want to be paying attention to that to understand what's going on. Okay, now let's look at efficiency. Again, this is looking at how many commits are we seeing per branch and by user and by day, and how many lines of code are being committed. What you want to see here is you want to see more commits in your development environment than in your release environment, obviously. And you want to see more commits, you want to see more lines of code committed. Again, be careful, because then you're going to start seeing people committing useless lines of code and you're going to get an inefficient code base. But you want to see things stay relatively consistent and flat across here. And then, is my code quality improving? And here we're looking at the performance of our unit tests, and there's 2 key metrics here. One is, are we passing, failing, or skipping our unit tests? Skipped and failing unit tests are important to understand. Here you can see that we did have a dip in our unit test passage. This was a release that never made it to production, and development stopped, and people went back and said, okay, why are we failing our unit tests? What's wrong? Do we need to fix our tests? And in this case, no, we need to fix some code that was problematic. And then we need to look at code coverage. Code coverage, as you guys probably all know, is how much of our code are our unit tests exercising? And if they're not exercising all of the code, then that is a problem. All right. And then, of course, a key one is our performance improving? I'm going to spend a couple of minutes talking about this, because this is critical, because this is the best way to show continuous improvement. And it's the best way for a development organization, even a small development team, to show their value, because you're showing continuous improvement. And you can engage in what I like to call quality speak. You can say, look, with our people, we are faster, we're deploying more often, and our code is running better, more efficiently, fewer errors, and this is happening over time. Every release gets a little bit better and a little bit better and a little bit better. And as long as you can continue to show that, then you're showing value. So what we've done here is we've collected the GitHub hash signature for each release, and we're annotating our performance metrics with the Git hash. That way we can quickly and easily tie our response time back to the particular code build. And what this means is, even in a canary deploy, even in a blue-green environment, even if we're slow rolling a new release into production, you can always look at the build and understand what build is being run and understand its performance. All right. Finally, we talk about whether or not our processes are working. So this is really metadata, information about our processes. We want to instrument and measure, in this case, our Jenkins pipelines, and understand what's going on with them. How many of them are working? How many of them are failing? Why are they failing? Because if they are failing, we need to fix that. And how long are they taking to run? Now, typically a long-running Jenkins pipeline or a long-running CI/CD pipeline in general isn't a problem. The fact that it's taking 12 minutes to get code deployed as opposed to 5 or 6 isn't always a problem. Certainly if there's a large delta. If last week our pipelines were running 5 minutes, a particular pipeline was running 5 minutes, and this week it's running 10, something has changed. And you got to figure out what it is and why that's happening. All right. And then, of course, we can drill into break this information out by other facets. We can look at events by team. We can look at events by outcome, by their source, and so on, just to understand what's working and what isn't. Because any process that is adding friction, by definition, is wasting your resources. And so you want to make your processes as frictionless as possible in order to be delivering your services quickly and efficiently, reducing the toil on your developers, and keeping everybody focused on what's most critical to your business. Okay, so once we've talked about that, now let's talk about measuring our code performance. We've talked about measuring the developer's performance, but they're creating code, and we want to make sure that the code they're creating is the best possible code, running in the most appropriately sized environment. Now, in order to do that, in my opinion, if you're doing that, you're really going through a digital transformation, and you need observability. You need some way, you need some platform that is open, connected, and programmable in order to collect that information and visualize it. Without that, or if you've got a bunch of disconnected stuff, it's not going to be as easy to stitch that together and understand the full experience. So briefly, because I've run into people who don't understand this concept, I want to talk about what observability is. I'm going to do that by contrasting it to the old practice of monitoring. So monitoring requires that you proactively understand how your systems can fail, and you instrument to catch those failures. In other words, you have to know the modes of failure. My application always fails because the database goes away. Okay, so I'm going to put up a database monitor. My application always fails because it runs out of disk space. Okay, I'm going to put up a disk space monitor. That's great when your application environment is predictable, and that's great when you know what the modes of failure are. That doesn't work in modern microservice, containerized, and other systems. These systems are much more complex, they're rapidly changing, and you're not always going to know your modes of failure. And by the time you do understand your modes of failure and instrument them, they've probably changed anyway. So instead, what we do is we bring in observability. Observability brings transparency to your systems, so you can identify and resolve problems regardless of their source. I think a good way of conceptualizing this, for me at least, is monitoring. If I'm doing monitoring, I have to create a list of questions that I'm going to ask my application, and I'm going to configure my application to answer those questions. Do we have enough disk space? Yes or no. Is the database still up and running? Yes or no. With observability and with monitoring, I don't have to, if I want to ask another question, what's the CPU doing, for example, if I haven't already thought about asking that question up front, I'm not going to be able to get it answered. Observability, good observability, means that you should be able to ask any relevant question about your application or its environment and get an answer to it without having to know that you want to answer that question up front. So how do we do that? We instrument everything. We need to unify our telemetry. That means we need to pull in metrics. We need to pull in performance events. We need to pull in log information. We need to pull in application traces, user information. pull it all together into a single observability platform. Now, there's typically two ways to do that. One way is with proprietary agents. You're going to get somebody's solution. You're going to add those agents in, and they typically are an easy button because they're easy to deploy and set up. You're going to integrate with whatever your cloud hosting provider happens to be. In this case, Amazon is always a great choice. And you're going to pull information from the low underlying services, things like your container, your Kubernetes containers, Amazon Container Service, and the rest. As an alternative, you can use open source and third-party data. You can use things like Micrometer, Prometheus, Zipkin for traces, and other sources. The key is the agent data, the proprietary agents are typically pretty easy, and you drop them in, they're fire and forget, they're going to collect the information you need, or they should. Third-party data requires extra coding, which is nice, and there are many organizations that like doing that, but organizations that don't like doing that, organizations that say, look, I just want what's off the shelf, I want to spend time writing code, not writing instrumentation, you have both choices. And of course, in organizations that are relatively large, where there are lots of autonomous teams, you want room for everybody to be able to make their own choice. And then you need to be able to pull in business key performance indicators and other custom metrics. If I'm running an e-commerce site, maybe I want to know how many shopping carts are passing through and the value of those carts. If I'm running a supply chain business, I want to know what's going on in my supply chain. Being able to pull in those business KPIs and those custom metrics is critical. And no matter what you're doing, having that single platform to visualize them so that everybody can see what's going on elsewhere, all the dependencies, is again critical. With that in hand, you can begin continuous improvement. You can measure the risk versus the reward. Is my performance continuously improving? Are we more agile? Is our code quality improving? Are we using our resources efficiently? And are we using our resources efficiently? If you can answer those 4 questions, you can then go to your managers and their managers and your business stakeholders, and you can show them all the value that you're bringing to the business. And that's key for maintaining your positions. That's key for getting the resources you need, and key for expanding and bringing more value and being seen as somebody who brings more value to the table. So how can we measure things like that? Well, it can be pretty easy. Measuring our risk versus reward. Let's simply look at the number of deploys versus application response. Here we can see our deploys, our level of deploys have gone up. Our application response is staying pretty flat. So we're deploying more often, application response is staying good. Even better would be if we were deploying more often and application response got better. Are we more agile? And we talked about this earlier. I want to understand how long it takes for a change to go from a ticket cut in Jira or a new epic or story to code deployed into production. Again, these are the kind of things that you want to see. You want to see that time coming down. You want to be able to show that you as technology, you as the developers, can get from an idea to deployed very quickly. And then, of course, is our performance improving? And the key way to do that is to understand what your end user's experience is. How many of my users are satisfied with their sessions? How many of them are quick enough? How many sessions are running fast? What are our load times looking like? How many are tolerating it? How many are saying, you know, this is fast enough, but I wish it were faster? And how many people are frustrated? In other words, for how many users are experiencing performance that is too slow or experiencing an error? Because no matter how fast your applications are responding, if they're seeing errors, it's likely they're going to get frustrated, they're going to lose faith, they're going to walk away. They're going to either stop using your service, go look for a competitor, or whatever else. And then again, and you can see here in this dashboard, let's identify our top improvement opportunities. What pages, what transactions in my application are the slowest? Why are they slow? Because I want my developers to go and spend some time fixing that and making things better. And then, as I've been saying all through our chat this afternoon, are we using our resources efficiently, especially in cloud environments? Because as you guys all know, our friends at Amazon and all the other commercial cloud providers, they expect a check at the end of the month. This isn't the old on-prem days when if you had 5 servers and really only needed 1, there was really not a large penalty for that. Here, if you're oversized, somebody's got to cut a check to Amazon, and they're going to want to understand that. They're going to want to understand where the expenses are going very quickly. I've got a couple of customers who are on cloud journeys. And early on, they said, we're going to the cloud, it's going to be cheaper, we're shutting down our data centers, and everything's going to be great, we're going to be saving a ton of money. And then they found that they weren't. They found that the savings that they were realizing were not as great as they expected. And they went back and they looked, and what they found is they've got lots of resource inefficiencies, and they need to be able to recognize those inefficiencies and rectify them. A good observability platform will help you to do that. Here, for example, we're looking at an anonymized dashboard that's showing cloud optimization for Amazon. What we're looking at here are cloud resources that are underutilized. And the underutilized definition that we're using here is simply low CPU utilization, low memory utilization. And anything that's using too little, we're able to show that it's underutilized. We're able to make some suggestions about what an appropriate sized cloud resource would be, and then show some real dollars attached to it. So that's the end of my story. I'm just going to put in a quick plug for New Relic. We are the industry, as you see here, we are the industry's largest and most comprehensive observability platform. We can help you to do all these things. Everything that I talked about here, I showed you some New Relic dashboards. Everything that I've talked about here are things that are well within our capabilities and quick and easy to implement and bring a ton of value. With that, again, my name is Alec Isaacson. My contact information is there. You can find me via email. You can find me on LinkedIn. I've got some blog posts on New Relic's website at newrelic.com. And with that, we can either take some questions directly here, or we can move over into a breakout room and take them there if anybody's got them.